This is our third information about climate change and natural resources. Today we'll be talking about alternative energy and climate change and what solutions look like. So one of the things, hopefully that's a review for you, is that idea of renewable fuels versus non-renewable. Renewable are resources that can be replaced over a short period of time, usually defined by about 100 years or so. Non-renewable are ones that take long periods of time, anything over that 100-year mark. So some examples are trees, water, solar, wind, geothermal for renewable sources. And those can also be things that don't get used up, like geothermal doesn't get used up. Whereas non-renewable resources examples would be something like natural gas, coal, oil, uranium, metals, things that either just flat out run out, like uranium degrades or gets used up, that sort of thing. Benefits of renewables, they're usually clean or they don't. And by clean, that can mean like carbon, like particulates like soot, or it can also mean carbon dioxide, like it doesn't produce carbon dioxide. Some of them actually reduce carbon dioxide, and we'll take a look in detail about those later. Some of the drawbacks of renewables, they usually need infrastructure changes. Our infrastructure is based off of fossil fuels, and so they need infrastructure changes. You'll notice down at the bottom you have a slide that says about infrastructure. We'll talk here as we go again about what that infrastructure means. And then you always have that chicken and the egg thing. Well, do you provide the renewable resources before there's demand, or do you wait for the demand because you need more alternative energies? And then what happens is one doesn't really drive the other when we're talking about our supply and demand economy. Non-resources benefits are there's the infrastructure, the things we need to use it are safe and in place, so it's inexpensive, it's easy. But the drawbacks is they do produce carbon dioxide. We're limited then because it is a non-renewable resource. And then you have all the global politics and money that's involved. So when we look at U.S. energy consumption, renewables tend to make up about 5% of our energies, where non-renewables make up about 95% of our energies. Looks like I'm missing a percent sign there. And so we use mostly non-renewable resources. So what exactly is that infrastructure piece I mentioned? It's the know-how plus the equipment and the logistics. So in other words, we know how to use the fossil fuels. We have all the pipelines and refineries and the pieces and parts, the gas tanks, the gas pumps, everything that's in place already to make us be able to use it. And so that means the logistics part, getting it where it needs to go, purchasing it, all of that. It's every so many miles. So it's really easy to know, I'm almost at gas. Oh yeah, there's a gas station just kind of down here on the corner. All of that's in place and makes it work well, which makes it cheap. And so all of those pieces together are infrastructure. So whenever we talk about renewable resources and making a switch off of fossil fuels, infrastructure comes into play. And we always have to think of that's going to come into impact those alternative fuels. And so the infrastructure is part of that chicken and egg thing, which has to come first, the infrastructure or the demand. And so that's one of the solutions that will need solved by hopefully our generation and yours. So what do? We've been talking about global climate change and the impact of carbon and what the impacts of that are and what their evidence is. So now, we can't stay in that spot of, oh my gosh, everything's horrible. We have to move on to, okay, what do we do about it? So alternative fuels are one of the answers. And we always want to ask the big three questions. Is it clean? Is it renewable? And is it efficient? Because some of them may not meet all three of those things. We're going to focus in on several fuels. The first one is solar. So on the left-hand picture, you see a solar array. That uses an old infrastructure. And you'll notice in your notes you need to circle whether it's new infrastructure, old infrastructure, or both. And in the right-hand picture, you'll notice is a picture of Creighton University, actually, and their parking lot and the new solar panels that they put in there. Those are photovoltaic cells, and those are actually a new type of infrastructure. So there's two types of solar energy. There's passive solar energy where, you like stand in the sun to warm up. So anytime you're using the sun to warm something up, that is passive solar energy. And then there's active solar collectors like the solar array or the photovoltaic cells in those pictures. So in the solar array, you're actually in the center there, there's a tank of water that's heated to build steam to turn a turbine. So it uses old infrastructure. And then it doesn't produce carbon dioxide, and so that would be nicely worked into our infrastructure. The photovoltaic cells, on the other hand, those are kind of new, and so we need to produce those solar panels and create those, and so that would be new infrastructure. Solar in general, though, is non-polluting, no CO2, so it's clean. The efficiency one is where we there's some arguments for and against, because can you ever be 100% efficient with solar energy? No, it's three-dimensional ball of nuclear fusing gas, so we can never capture all of the sun's energy. We're always going to lose some. We already know that only 50% of it actually makes it down to Earth's surface, so there's that too. Current equipment is costly because it's new infrastructure, so that makes it kind of a drawback. And then also, the sun's not always out, so when you need electricity, you're not producing any electricity. We need it at night when we're home doing our dishes and our laundry and turning on the lights, and so you need some sort of backup system with solar for those cloudy days, those winter days, or at nighttime. Then the next one is nuclear fusion. Fission. So fission's the opposite of fusion. We talked about fusion in stars where we smash the atoms together to make something bigger. But now what we have is nuclear fission, and that's when we're breaking those apart. And so when we're breaking them apart, that is fission, and that provides approximately 7% of energy for the U.S., and that also releases energy. We capture that as heat, and we use that to generate steam from a water source, which turns a turbine and makes it old infrastructure. So it's very efficient. We get lots and lots of energy from very little material. It's also what we would call on demand. So we, in general, are trying to hold back that reaction. And so if we need a little bit more for that hot summer day when everybody comes home at 5 o'clock and turns on their air conditioner, we can just crank the dial a little bit and generate some more electricity. There's no carbon dioxide with nuclear fuel. It is all carbon dioxide free. However, it does have nuclear waste. So there's just a different sort of thing to deal with. With nuclear, there's kind of this perception of safety issues because of the chain reaction that's happening. And of course, we have the Japan tsunami earthquake scenario, and those nuclear fuels we do have to do something with. And it's not renewable. The thing about the safety issues, though, is there's so many safety regulations in place that you can't actually get new nuclear facilities because it's too stinking hard. So nuclear kind of has that drawback as well with theirs. If you search National Lampoon's Christmas Vacation, there is a video about this. I'm not going to put it here in this clip video because I don't want our video to get blocked for copyright issues, but if you go on YouTube, you can usually find it, but that is an example of it being on demand. The next one we're going to talk about is wind. Wind power is electricity generated by a turbine. You guys have a lot of practice with these after doing our project. And so windmills are the old-fashioned kind that are used to pump water, but turbines, you saw how we spun that little gear, and inside that little tiny piece of metal that was on our towers are magnets that are going around inside of a copper wire, and that induces a current and generates electricity. So anything that turns a turbine like that is old infrastructure. We know how to use it, we know how to make it work, and it's going to do that well, which that makes it renewable, that makes it clean, it makes it efficient because we know how to generate that. Wind has the possibility of providing 80% of the U.S. with electrical energy, and that's from North Dakota and South Dakota alone. The problem is where we can generate that, in the Midwest, is not where we need the electricity. We need the electricity in our high population density places like Nevada, California, New York, Florida. And so how do you get that energy from the Midwest to those coastal regions? And that's the problem. We need a smarter grid system, and so we do need to upgrade our electrical grid. So there's another $1 million. If you're into electrical engineering, maybe you could be our next energy guru. Wind is dependable because the earth is heated unevenly, but it's not necessarily reliable in that sometimes it blows fast, sometimes it blows slow, sometimes not at all. And so you still need a backup solution for that. It does take up land, and there's technology that goes with it, so that can be cost prohibitive. And the technology still has some issues in terms of size and transportation. We've kind of made those as big as we possibly can to generate electricity. So in the image, what you see is a vertical turbine. Kind of looks like an egg beater. Those are actually made to take up less space to kind of solve that. Noise pollution is another one that's often listed. I tend to disagree with that. So on the keynote itself, what you'll see is you can click this video here on this left-hand side. That video was taken by me off of I-80 in Iowa. I'm about, I'd call it about 500 yards maybe at the most from that turbine right there. And I-80 is behind me, and when you listen in the video, you can hear the wind and you can hear the interstate, but you can't hear the turbine. So I tend to argue that turbines are not noisy. I don't think they're noisy. And then the same image on that same stop, I got to see a truck try to go around an on-ramp, and that is one of the blades. So that kind of gives you an idea of the size of that. And so that one blade, it took him like 3 tries to get around that corner. So we can't make those turbines any bigger, because if we did, we can't transport them and get them to where they need to go. So if you can figure out how to make the same amount of electricity from something this size and make it smaller, there's another $1 million for you. The next one we're going to talk about is hydroelectric. Hydroelectric, we've currently maxed out pretty much around the United States. It's power due to falling water. So literally you build a dam. This one happens to be the Hoover Dam. The water stacks up behind it. You let the water flow down through that turbine down there at the bottom, and it turns the turbine to generate electricity. So this one's old infrastructure. It's renewable, it's clean, no carbon dioxide involved, and it's really efficient. The problem is hydroelectric dams have limited lifetime. So the Hoover Dam is one of those that's kind of getting near the end of its life. It's getting kind of expensive to repair. It kind of needs to be redone. But how do you redo that when that thing is so huge? It's got so much water behind it. What do you do next? And then you also have to think about water rights of those downstream and land rights of those upstream. You see how that water builds behind all those. If you were a landowner behind there, you're just now flooded. And if you use that water downstream, that's now changing the ecology of that stream. So can we really ethically think about putting in new hydroelectric dams? Maybe not. And so the majority of U.S. locations are already developed in terms of what we can get out of them electrical-wise. So they're looking now at things like tides and waves. How can we utilize those without impacting the ecology? The next one we're going to talk about is geothermal. Geothermal actually uses heat from the Earth's core to do 2 things. You can either have a heat pump or you can generate electricity. So the steam kind is the kind that generates electricity. So they use a hot spot, like a geyser or some form of lava. They use that heat source then to heat up water to generate steam to turn a turbine. So those are limited by the amount of water in an area and the amount of steam in an area, and by those hot spots. So those you can't really develop much anymore either. The other kind is like what we have here at Westside. We have a heat pump, and so what those are, and that's in that image there, is you have a series of pipes that run through the ground. That one's a horizontal system. Ours here at Westside is vertical, so it goes over, down into the ground, then back up, then over, down into the ground, back up. And the ground below the frost layer stays at about 50 degrees. So you can imagine that cold winter air travels over these pipes that have been warmed to 50 degrees. So it goes from that, 0 to 30 degree air, all of a sudden gets warmed to 50. Our furnace only has to take it from 50 to 70, so we're saving money on our furnace, on our heating bills. And in the summertime, what happens is that 90 degree air goes across those pipes at 50 degrees, and hopefully we don't have to run the air conditioner. So a heat pump can work by geothermal pretty easily. Those are pretty accessible. You could install one in your backyard. It does take a little bit of space though, so that's one of the limitations of geothermal, is that equipment and the space around getting those installed. The next one we're going to talk about is biofuels. Biofuels are really important to Nebraska economy. We produce ethanol here in Nebraska out of corn, so it's a big, huge one to our state. And they appear to be the most promising for replacing current fossil fuels or providing that transition off of fossil fuels. And so this is old infrastructure. And it uses that crunchy stuff of the plant matter. They ferment it to make ethanol. And you can also make biodiesel from used cooking oil. So if you ever hear about a restaurant getting broke into, it's usually because they're stealing the fry oil to make biodiesel. And you could do that in your garage. The thing about biofuels is they have this perception of not being efficient, and so if you look at it in miles per gallon, ethanol usually loses. But if you look at it in cost per mile, ethanol wins. So think about it this way: if we had a barrel of oil for 100 units, and knowing that nothing is ever 100% efficient. Oil takes 1 unit to create, transport, and store. 8 of those units goes to consumers to use in terms of our gasoline or other oil products. 91% goes to waste. If we look at biofuels, took a same barrel, same 100 units of energy, it would take a little bit more to create. 7 units to create, transport, store, but 71 of those units goes to consumers to waste. And then again, if we look, so what that means is it's cheaper for you to purchase, which then when you put that in your car, if you look at your cost per mile, that number goes down, even though your miles per gallon may go down as well. So your cost per mile usually makes that win. So we have to shift our public perception. So when we're talking about sustainability, the people here are a big deal. More benefits of biofuels: they lower the use of pesticides. On that last image, we had a picture of miscanthus. That's a grass that grows back every year. So you don't have to use any type of herbicide or any type of insecticide on it so that you can grow them organically, and they grow back year after year, so there's less soil erosion. And it can also enhance habitat diversity in terms of animals and insects and stuff like that. Then you take that sludge that's left over and you can throw it back out onto your fields, and you can fertilize your fields with that old sludge. And so it can be very, very it doesn't really generate a whole lot of waste. The other benefit is it's a net zero carbon dioxide. So the plant uses carbon dioxide for photosynthesis, and then that's the same carbon dioxide you get out when you burn it. So there's no gain to carbon dioxide in the atmosphere. It's a net zero. So that's pretty awesome. The problem with biofuels, though, is it uses a lot of land, and so that land's not there for development. So we like to put shopping malls and parking lots and housing developments on empty land, and so we wouldn't have that for fuel. So we'd have to come up with a different solution there. So biofuels is old infrastructure in that we can use it to replace fossil fuels, but it's also new in that it kind of has a little bit more water, so it tends to be a little bit more corrosive, so we would need to tweak our current infrastructure to use biofuels a little bit better. Hydrogen is one that's kind of starting to leave our radar now. Hydrogen is cool in that it works like a battery. They're called fuel cells. The hydrogen goes in, literally breaks apart. We use the electrons that are contained there to move along and work like a battery. It's zero emissions when it's burned. There's no carbon dioxide whatsoever because it's literally H2. So when it burns H2O, it makes water. But you have to make it without fossil fuels too, and there's the kicker right there. How do we make it if we're not already on alternative energies? A little problem. It's super efficient. You can get 1.5 to 2.5 times the miles per gallon of gasoline. Automakers were ready with the Toyota Mirai in 2015. But the auto industry is leaning more towards electric. They see a better market in the electrical industry, and that gets us to a point source versus a multi-source. We're really trying to get our carbon dioxide emissions down to one specific spot, the power plants. And then that takes all of our individual cars off the market. So automakers are saying, hey, this would be better to get us down to point source rather than multi-source. So let's get everybody an electric car. So that's kind of the way you see that electrical industry or that automotive industry moving. There is another movie that shows a hydrogen demonstration of burning hydrogen. It's kind of fun. It's not how it works in a car. It's just literally for fun. So hydrogen's challenges are the technology, storage on vehicles. The fuel cells are really short; they don't last very long, and so how do you mitigate that? And we need that true carbon dioxide production free needed, and we just don't have that right now. And again, for all of our alternative fuels, we have that chicken and the egg. How do you get more availability if you have low demand? How do you get more demand if you have low availability? It's just that same thing. All right, so that is our alternative fuels. I would say pause, go back, rewind. I know I went super fast, but thanks for watching.